This is Chapter 1 for this project. If you did not watch the introduction, I strongly recommend you to go ahead and watch it before continuing this one. The link will be in the description. For those who want to follow along with this project, I will provide a link to this template in the description. Kindly follow the next steps to set this template as reference for your project. Inside 3ds Max, set your system unit to meters. Choose generic units to remove the unit indicator. In the left viewport, create a square plane with 492 mm in length and width. The number of segments does not matter. From the creation panel, disable the real-world map size. Before or after the creation, it does not matter, as long as the object is in its logical state. Press M for the materials editor. Create a standard material, and wire the template to its diffuse slot. Keep all files related to your project organized inside the project folder. For convenience reasons that we previously discussed, use relative path in the file settings. Assign the material to the plane. After setting your project scene correctly, create a cylinder with the given parameters, then align it to the world center. Create the cylinder in the left viewport. Disable the real-world map size from the creation panel. Toggle see-through on or off for better alignment. In the previous video, we have added this primitive cylinder to match the scale of the reference rim. Today, we shall start the modeling process to shape this primitive cylinder to a very optimized version of the reference rim. Select the side polygons, as shown. Enable Ignore back faces while using the Selection tool. Use the Insert tool to insert a loop that match the mounting area. Remove the extra loop. Grow the selection, then use the Insert tool to insert a loop at 5 mm. This will be the thickness of the rim's diagonal edge. Add another supportive loop at 5 mm. Later, we will move this supportive loop to another 10 mm. Meaning, you should insert that supportive loop at 15 mm. Select the back faces, insert a loop at 25 mm, then delete the selection. After laying down all the required supportive loops, now we are going to manipulate the available edges to match the arm scale. Select the edges in between the arms, as shown. Scale them down to match the reference. Use local as reference, and the transform type in for precision. Repeat the same process for the spaces inside each arm. switch the coordinate system to view, enable constraint to edge, while scaling the edges, in order to move them towards the center. Then, switch back to local, and scale down the selection to match the reference. This is the shape of the mounting area. However, I forgot to add a supportive loop for the logo. We could add a supportive loop with the insert or the swift loop, then use the loop tools to equalize the loop segments or edges. Obviously, that was not the solution I did choose. Remember to work smart, not hard. In order to curve the rim, select all polygons in the mounting area. Disable any constraint, then use the Move tool to move the selection inward on the x-axis. When adding a supportive loop between a circle and a regular loop, 3ds Max will average the shape of the new added loop according to the shape of those original loops. To equalize the new loop edges, use the circle option from the loop tools to turn the curvature into a circle. Bevel the side polygons by -15 mm. I decided to place a supportive loop closer to the bevel edge and delete the old one. Now, let's create the gaps inside the arms. Select the polygons over the reference gaps, as shown. Use the Insert tool to insert a loop at 5 mm in each group. Adjust the scale of the inside edges to match the reference. Select Similar is a very handy feature that will save time while using this modeling technique. Manipulate the edges over the gaps between the arms, as shown. Move the selected vertices on the negative direction of the x-axis to bend the arms outwards. Use the Insert tool to inset a loop at 5 mm in each group of the current selection. Bevel the selection by -25 mm. Then hit Delete on your keyboard. Repeat the same process for the spaces inside the arms. We shall continue our work in the next chapter.